perceptron algorithm on the Boolean and function. Okay, so Boolean function and with the initial weights W1 0.2 and W2 minus 0.2. Learning rate is 0.2 and bias 0.4. Fn is activation function. The value of Fn is greater than or equal to 0. Then the output is 1. Otherwise this is 0. Okay. This is the diagram of the perceptron. Where x1 and x2 is the featured, that 0 or 1. Then w1 and w2 are the initial weights. 0.4 theta represent the bias, and this is called our activation function, sum of activation function, and y is the output. Okay, so in the AND gate question, truth table is 0 0, expected desired output is 0 0 1 0 1 0 0 and 1 1 1. Okay, here we write the formulas. Activation function y equals to step first features into their corresponding weight plus second feature and her corresponding weight minus theta. This is called activation function. How to find the error? Error et equals to output, desired output y minus estimate output. This output are actually come and updated weight. If the output are not desired, then we change our weight. How to change our weight? It's called theta. Theta means we already said theta is a learning rate. Okay, theta into error into feature, first feature. Okay, it's called a delta weight. Okay, then we update our initial weight with old weight into delta weight plus delta weight. Okay, then this is our first feature x0 and x2 0. This is our second feature, and this is the weight of the first feature, second weight, and this is a theta, means a bias, and this is our this is our learning rate. This is our learning rate 0.2. Okay, in the first epoch the x1 and x2 are 0 and desired output is 0 also. So our estimate result is first feature into our first weight 0 into 0.3 plus our second feature into second weight minus 0.2. This is, and this is whole by minus our bias minus 0.4, and the outcome is minus 0.4. Okay, these are less than 0, so we can say this is, we can accept as a 0. So is, what about the error? Error estimate is y desire minus y estimate. So y desire is 0 and y estimate is 0, so value is 0. Okay, so here the no change the weight, so it is 0.3 and 0.2, no change. Okay, same as for our second statement, where the features are 0 and 1, desired output is 0, then we apply the activation function 0 into 0.3 plus 1 into minus 0.2 whole minus 0.4. This is our bias, and the outcome is minus 0.2, that is less than 0. So except is the 0. Then we subtract the y desired minus y estimate. So our value become 0 minus 0, just basically 0. Okay, so here we no change our weights, no change, 0.3 and 0.2. Same this for this step. Y into our first weight is 0.3 and our featured is 1, plus here weight is 0, to write 0, into our second weight is minus 0.2 whole minus 0.4, this is our bias. Then the result is minus 0.1, this is less than 0. Okay, so our output become, we write as 0. Then our error value is 0 also, so here we no change, 0.3 and minus 0.2. Then our next featured is 1, x1 and y1. The value is 1 for x1, 1 is for y1, and the desired output also 1. So we apply the activation function here. So first feature 1 into first weight 0.2 plus second feature 1 into second weight minus 0.2 whole minus 0.4, this is our bias. So our outcome is minus 0.3. We are obviously less than equals to 0, so we consider as a 0. So but our desired outcome is 1, but estimate outcome is 0. So the error is come 1 minus 0, result is 1. So 1. So here we change our weights. Okay, so our desired outcome and estimate outcomes are become same. So that's for the input 1 on the weights are update. So this is our formula to change our weight. Delta W1, this is called learning rate into error ET, and T for term first, then x1 is the feature. Okay, then we write our learning rate 0.2, error is become a 1, and first feature is x1, you write x1 here. So it is come as a delta W1 value is 0.2, then W1 become, W1 is already 0.3 and W1 is 0.3 and our delta W1 is 0.2, this is called 1, so value is become 0.5. Same apply for W2, is come to minus 0.2 learning rate, then another feature is 1. Okay, then the error value is 1, this comes 0.2, and they find out the W2 minus 0.2 our value of the W2 plus 0.2 the value of the delta W2. Actually here we update the value of W2, so it's become a 0. Okay, we apply it in activation function. So 1 into 0.5, 1 is the first feature, this is a new update 0.5 weight, 1 is the second feature, and the updated weight is 0 corresponding, and whole minus into 0.4, these are bias, and it's become a 0.1, this is greater than equals to 1, so value become 1. So this value is come, so error rate is 1 minus 1 equals to 0. So here the changing the weight. Okay, in the come from the epoch 2. Okay, epoch 2 the feature is start from the 0 and 0, and the weight is updated right now 0.5 and second weight is 0, theta is basically 0.4 and learning rate is 0.2. Okay, so first feature 0, and her weight is 0.5. Second feature is 0 and her weight is 0. Minus 0.4, this is our bias. So output is minus 0.4 is obviously less than equals to 0. So we write is 0. Okay. So what about the error comes? The error rate y desired minus y estimate to become a 0. 0 minus 0, obviously 0. 0 minus 0 equals to 0. Here we no change our weight, no change. Now our second feature. Second feature x1 equals to 0. We multiply with the weight 0.5, and our second feature is 1. We multiply the second weight 0 minus our bias 0.4. Then this comes minus 0.4. This is basically obviously less than equals to 0. So y estimate is 0. Then we find out our error. This is basically y desire minus y estimate. 0 minus 0. 0 minus 0 obviously 0. Here we no change our weight. The weight is basically 0.5 and 0. Okay. Then our next feature is 1 and our corresponding weight is 0.5 plus our next feature is 0 and our corresponding weight is 0. Whole minus 0.4, these are basically bias, I already said. And when the activation function is done, the value is comes 0.1. This is obviously greater than equals to 0. So right is basically 1. Okay. And when we find the error value, basically it's come 0 minus 0 minus 0. Okay. So this is a minus 1. So this is not a desire. So we update our weights corresponding with the value. Inputs are 1 and 0. So in delta W1, this is a learning rate sign and this is the error sign and this is the first feature. So our learning rate is 0.2 and error comes minus 1 and the first feature is 1 in that case. Okay. So W1, delta W1 comes minus 0.2 and we update our W1 with the old value of W1 plus W1. Old value of W1 is obviously 0.5. So we write it 0.5. Then plus minus minus. Then we write a delta W1 0.2 to our new W1 value weight is come 0.3. Okay. Same is for weight 2. So this is our learning rate 0.2. Then minus 1, this is our error value and this is our second feature 0. Basically this come is 0. Then we update our weight 2 with the old weight 0 and our delta W2 value 0. This come obviously 0. Okay. Then 5 the activation function, or we write featured 1 and her weight 0.2 plus second feature and her weight 0 whole minus 0.4. Okay. Then our value is come 0.3 minus 0.4, obviously minus 0.1, the less than equals to 0 to consider as a 0. Okay. So here we change our weight 0.3 and 0.2. Then our second feature is 1 into 0.3. 0.3 is the first weight of the feature and we sum with our second feature and her weight and whole minus by 0.4. This is a bias equal to 0. Okay. Then 0.3 minus 0.4, they basically come minus 0.1. Just consider is a less than 0, so we consider as a 0. But this is our estimate result. But our desired result is y. So error value 1 minus 0 equal to 1. Now we update our weights. Update our this weight. Okay. So we update our result. For input 1, 1 weights are updated. Same is this is a landing rate, this is our error value, this is the first feature. Landing rate 0.1, error value 1, wave 1. So delta W1 value is 0.2 and we update a W1 value with a W1 0.2 and W1 is 0.3. Our new weight is 0.5. Same for W2 and our weight is come to 0.2 and 0.2 and we check it here 1.01 plus 1.02 and minus 0.4. They are basically come minus 0.2 already said. So our updated value is come 0.5 and 0.2. Okay, this is a new updated value. And we then our epoch 3 is come. In our epoch 3, our weight is W1 and W2, new weight. So same is for we apply it same for our value first feature, and there are corresponding values 0.5 and second feature corresponding weight is 0.2 and minus the bias 0.4 and this comma minus 0.4 obviously less than 0, so we consider as a 0. So error is comes 0 with 0 minus 0. Here we no change our weight 0.5 and 0.2. Same as for our next, where the feature is 0 and we sum with as 0.5. Now we multiply with 0.5 plus some 1 is our second feature and our weight is 0.2 and we minus whole by 0.4. So our activation function result is come minus 0.2, basically less than equals to 0. So we consider as a 0 and our error value is 0. So here we no change because our error value is 0. So this is basically 0.5 and 0.2. Okay, state is no change. Same for our next two features. There comes 1 and 0. 1 into 0.5 is the first weight of the feature and it is our second weight 0. Second feature is 0 and her weight is 0.2 and whole minus 0.4 is our bias and the activation result is come 0.1 is obviously greater than equals to 0. We write is 1. So desired output is y equals to 0 minus 1 is estimate. So our result is 1 minus 1. So here we need to update our weight. Okay, change the weight 1 comma 0 out. So our estimate value weight is come 0.3 for first weight, second weight is come is 0.2. We apply here our activation function, so it's come minus 0.1 is obviously less than equals to 0. Okay, so you write it 0.3 and 0.2. In our next feature here, a feature is 1 and multiply with first weight updated weight, this become a 0.3 and plus a second feature is 1 and we multiply 0.2 is our second weight and minus 0.4 is the bias. Okay, and our activation function result is come 0.1. It obviously greater than 0. So our value become 1. So yeah, then our value become a 1. Then no issue because 1 minus 1 equals to 0. So it come with a no change. The weight as 0.3 and 0.2. Then our epoch 4 is come, where updated weight as 0.3 and 0.2. Okay, and our learning rate is 0.4, and learning rate is 0.4. This is basically this, and the alpha, and our bias is 0.2. okay, actually a mistake here as symbols. So in the weight, in the feature 0 and 0, and our weight is 0.3 and 0.2, and we minus it whole with a 0.4. This the outcome is activation function is minus 0.4, is basically less than 0. So error is become 0 minus 0, 0. There is 0. So here we no change our weight 0.3 and 0.2. Next features is come 0 and 1, 0 and 1, and our corresponding we multiply with at the corresponding weights. First is 0.3 and is 0.2, and sum it. Then whole minus 0.4, this is basically our bias. So our activation result is come minus 0.2. This is basically less than equals to 0. Okay. So it applies 0. Then our error is 0 minus 0, basically 0. So here we no change our weight 0.3 and 0.2. That's it. Our next feature is 1 and 0, and our weight is 0.3, and we multiply with is our feature 1. Our second weight is 0.2 and multiply with a 0. Okay. Then whole minus 0.4, this is basically our bias. Then our outcome is come activation function, there basically result is minus 0.1, obviously less than 0, we accept is a 0, and our error is come 0 minus 0, there basically 0. Here is no change of the weight. Our second feature is 1 1, so basically write it 1 and 1, and first feature weight is 0.3, we multiply it with weight and feature, then plus symbol. Then this is our second weight 1, and we multiply with 0.2, this is our second feature, whole minus 0.4. okay, this is our bias. Then right is 0.5 minus 0.4 equals 0.1. basically the 0.1 is greater than 0, so we write it 1. So our desired output is 1 and our estimate output is 1. So 1 minus 1 equal to 0. The error is becoming 0. So no issue in that case. And 0.3 and 0.2 they are weight, they are no change. Straight are in that case no change. Okay, so we can say it is observed that with the epoch 4 the perceptron learning and the weight are the updated to a 0.3 and 0.2, with which the perceptron gives the desired output of a Boolean and function. Okay, this is our mathematical representation of the AND gate on the perceptron. So our future updates are make the core Python implementation of this perceptron and apply it the perceptron on a Django. Okay, thank you. In my mistake, we have one mistake in here, because here the error value is 1 minus 1. In that case the error value is 1 minus 1, so this is become a 0. Okay, so we remove it. Sorry, this is become a 0. Okay, and one change is here, this is also become a 0. Okay, nothing to change, all are right. So this is all about the video.